Today we have two eminent speakers with us, Professor Venkatesh Datta and Professor Shashank Shekhar. So welcome Professor Shashank Shekhar and Professor Venkatesh Datta.
Thank you. Namaskar.
Along with me, my director Deepinder Singh Kapoor is here, and so now we start the session. And I will give you some housekeeping rule, and after that, Deepinder Singh Kapoor sir will give you will set the context of this webinar, and further the speakers will show their presentation and express their views. So I am sharing my screen. So I hope the screen is visible to all of you. Once again, I would like to welcome you all in this webinar on urban groundwater sustainability, recharge and quality challenges. We are doing this webinar under the CSC MMCG and initiative making Ganga Basin cities water sensitive. And so for this webinar, we have around 715 plus registration from 26 countries across the world and 218 Indian cities. We have a number of participation from academicians, private sector, NGO, media and government. So we will discuss, I will like to tell you some housekeeping rule of this webinar. So please keep yourself muted unless you need not to speak. We will be recording this webinar. Please rename yourself with your name, and what if you have any kind of question, please put it in your question answer box. For any kind of chat and things, you can put your chat in the chat window. If you want to ask something, please raise your hand. So agenda of the today's webinar is first the context setting by Deepinder Singh Kapoor, and after that Dr. Venkatesh Datta will give his presentation on mainstreaming groundwater management into cities master plan, meeting the over extraction, recharge and quality challenges. After him, Professor Shashank Shekhar will express his view on the topic urban groundwater sustainability, recharge and quality challenges in a special context with Delhi. So I would like to tell you something about our eminent speakers. So Professor Venkatesh Datta is a professor at Babasaheb Bhimrao Ambedkar University at Lucknow, and he is a eminent scientist, and he has done very good work in groundwater and environment. Recently, UP state government has awarded him for his work in groundwater and environment. Our second speaker is Professor Shashank Shekhar. He is a professor and an academic researcher from University of Delhi. He is a distinguished scientist and academician with a proven track record of original research and eloquent teaching. Previously, he was working with the CGWB, and after that, he has joined Department of Geology, University of Delhi. So now I will hand it over to our director, Deepinder Singh Kapoor, for setting the contest and giving his view about the webinar. So.
participants of the webinar that the issue of groundwater is being addressed in CSC under the initiative of our water sensitive urban design and planning and green infrastructure focus. And although these are big concepts, and we would like to use this webinar and to focus on the contextualization in India on groundwater. And this webinar is not a one-off webinar. In the last 2 months, we've had a series of trainings where we have looked at issues of recharge, groundwater, water-sensitive urban design, stormwater plan, stormwater management. So we've also had a national consultation, and we've had a long set of series of discussions with the others. So we are looking at this in terms of our overall commitment to water conservation, water recharge in the urban areas. In this short presentation, I would like to focus a little on what CSC water program is, so that webinar participants can get some understanding. And I have just 3 slides at the end, which are raising some of the issues which we have encountered in CSC as part of our engagement in this initiative on groundwater and urban groundwater. So very briefly, this is what CSC does in a larger context, where water, wastewater and sanitation is one of the 8 or 9 programs we have in CSC. So the other programs in CSC are on air pollution and mobility, climate change, industry, pollution, environment education, sustainable food systems, municipal solid waste, habitats. So this is the kind of program scale or diversity of programs in which CSC operates. We also have a monitoring lab where we are also doing monitoring for not just water and wastewater, but for food and toxins and other issues. We have our center namely in Rajasthan, and Anil Agarwal Environment Training Institute, where we use the infrastructure for developing capacity and training programs. And we have a big communication and outreach, for which CSC is famous for the Down to Earth magazine, for our media and coverage and engagement, and through our websites. So coming to the water program of CSC, the water program of CSC is a program which flows from action research to advocacy to capacity building and cross-learning. And I will not go into the background of CSC, you can read all that, but essentially the approach of CSC, which we also follow in the water program, is not projects. We pick up action research, we do advocacy on that, and then we support implementation through a capacity development learning initiative. We don't implement projects ourselves. So this is a kind of a program we have, which is both rural, urban, and in FSM, fecal sludge management laboratory. The urban water program we have has a focus on climate change. Has a focus on climate change, water sensitive cities and climate resilient cities. So the program focuses on water sensitive. So this is where all the water programs which we are doing and which forms the background of this workshop or this webinar is listed. In the wastewater, we focus on sustainable state and city sanitation programs, where we are focusing on citywide inclusive sanitation, fecal sludge management, and decentralized wastewater and grey water systems. We also have a program in Uttar Pradesh, which is looking at supporting and scaling up of decentralized sanitation solutions, especially fecal sludge management in Ganga Basin. And we, of course, support the national programs. So this is the kind of, if you scroll down, these are the kind of things we do. We have publications, pilot projects. We have a knowledge hub, which is one for sanitation mount and one for water seasons. We have a capacity building program. We have research priorities, and we have a global outreach as well. So both at national level as well as some Asian and African outreach we have had. And our rural program is also on the 3 verticals of water, wastewater, and global. And in the water, our focus is on water source sustainability and institutional sustainability. So for example, drinking water source supply is a critical issue. We are working on ensuring sustainability of the water source as well as of the infrastructure, the institutions which will manage these rural water supply infrastructure. In wastewater, we are looking at this area of grey water and wastewater in addition to also to fecal sludge, which is generated there. And in global, our program is working in about 3 countries intensively, which we intend to expand in the coming years. These are a set of publications which are all available on our website. So you can see that. And lastly, our work on the lab, which is at the Nimli program. So here the lab is called the FSM lab, and the lab does other work also, but the team which is dedicated for the FSM lab is addressing both the water quality parameters and the biosolids parameters. So that amounts to characterization of fecal sludge and seepage, develop standard operating procedures, a focus on resource recovery. So our focus is very much on nutrient resource recovery and on the performance evaluation of these plants. Besides doing training of trainers and providing some referral services to anyone else who wants to do testing. So these are the parameters we normally test, biological and chemical. And this is the focus of our program at NIMI. So now coming to this topic here, groundwater management, I just have 3 slides here. We want to listen to our esteemed speakers, but I just wanted to pose these questions to them also, and of course to the audience. And these are what have arisen from the set of consultations we have done in the last 2 months. So what is the perspective, why, what, and how of groundwater management? I am sure the how the professors will take up much better in their presentations, but why and what we will share based on the consultations and discussions we have had. In the urban groundwater management, when we issue the why part, we are looking at this scenario. There is an inequity in the urban water supply. There is already a crisis of water shortage. Inequity means that people don't get water supply in the same measure. Everyone doesn't get. Some get more, some get less. Then there is this issue of managing water demand. We need to manage the water demand, and we also need to reduce the wastewater footprint. But how has it to be done is not defined. It's a good goal to have that you should manage water demand, but whose water demand will you manage and how? And whose wastewater footprint you want to reduce and how? That is quite an open issue. We have a large extent of urban built environment, but we also have large extent of congested slums and informal settlements. So our urban built environment is not like Europe or developed countries. It is much large in extent and also has very congested slums and informal settlements. There, the normative application of water conservation and green infrastructure concepts needs to be carefully applied. We may also need grey infrastructure. Grey infrastructure means more cement pipes and supply and drainage kind of systems to serve the areas which cannot be fit for water conservation. Then we also have the priority for understanding mapping of urban groundwater aquifers. So this is, we feel, the first requirement. Before you get into the recharge, you need to actually do that. We also have a mindless urban construction going on, which actually affects the aquifers and negates the potential of WSUDP and green infrastructure. So we need to also look at that. And then there is this importance of urban planning, which is now being downgraded. Urban planning is seen becoming a favorite hitting topic that urban planning has failed, but actually urban planning defines the entitlements of people. It is a legislative instrument. It's a very valuable piece. And WSUDP and green infrastructure integration should be, factored into the master plans rather than master plans being criticized. Now, the why part. These are 3 points which we got from a presentation or a discussion with Veena Srinivasan as part of our engagement. See, if you see, preservation of shallow water aquifers is actually helpful in these are the points from her presentation. So she was saying that these are actually helpful in some, for urban poor in some coastal cities like Chennai, where better management could reduce the saline intrusion in the coastal areas, and the urban poor in these people would use this groundwater, so it helps them in terms of improved quality. But in the case of Bangalore, the situation is different here. Why? Because this WUSUDP, because the Bangalore is located on the hill, and here the whole argument and the purpose of WSUDP should be that it reduces your energy and carbon intensive costs of pumping water from Kaveri, which comes from below. So if you have water recharge, then you can, reduce your energy and carbon footprint to a great extent by replacing Kaveri water or substituting it with the local resource. So the whole equity argument in the whole case is that that the poor should get a benefit of groundwater recharge, but this benefit will not come automatically, because where the groundwater happens, how is it extracted is not uniform. So unless additional work is done to ensure that the poor benefit from groundwater recharge, to assume that it will automatically happen is a fallacy. So I thought these are 3 good points on the why part of urban groundwater perspective. There is this diagram which shows that you can leapfrog. So there is also this assumption that this is coming from, again, the European experience, where you had water supply city, then in the late 20th century, 19th century, cities water supply was prioritized in Europe, then seaward systems came, so we became seaward cities, then drainage system came, we became drain cities. And then this issue came that let's look at sustainable urban drainage systems, SUDS as it is called, look at city waterways, look at city water cycle, and then we are talking of water sensitive city. So there is also this imagery that underdeveloped countries can straight away jump from water supply cities to water sensitive cities. Now there is a challenge here that this jumping may not be possible for underdeveloped countries, because the kind of infrastructure we have created so far does not meet the requirement of either a water supply city or a sewerage city or a drainage city. So what is perhaps required is a combination of grey and green infrastructure. Our slums and informal cities cannot move straight away into water sensitive cities. They may require drainage systems, they may require water supply systems, which they may not have water recharge systems possible in these areas. Similarly, these are the other points that how you do it, of course, we will not get into, but there is these 2-3 other points are listed. That you just go for a blind urban water recharge initiative may be a little risky in terms of where the recharge is happening, what kind of recharge is happening. And an understanding of city water balance is more than an accounting exercise of water supply and demand, which is currently the case of Amrut, where a city water balance has to be done, but it is done more as an exercise. And Therefore, WSUDP and main infrastructure have to be situated in the local context of a city and in the conflicts and power relations. So this is the kind of conclusions we were drawing, and I would now leave it open for our esteemed speakers to address, and for our esteemed participants also, if they can, input in the chat box as Charu was saying, and also to the participants. So we will start now with the presentations, and I would leave it for Charu to take over.
So thank you, sir. Now I like to welcome Professor Venkatesh Datta to give his presentation and communicate with the participants. So.
Sure. Thank you so much, Deepinder Kapoorji, for setting the tone and the context upright. And before I start, I would like to welcome my fellow colleague, Professor Shashankji, and all the participants who are attending this webinar. The purpose is to hope I'm audible and my voice quality is okay. So let me start with the structure of my presentation. Basically, there is a significant impact of built environment on water resources. All of us know that there's an effect on runoff, there's an effect on infiltration, and most of the urban development is happening on the phreatic aquifers. There's a layer of soil, and the water is stored in the aquifer and it is flowing. So it is in motion, it is in continuum with the other aquifers as well. So how to manage urban development with minimal damage to groundwater resources? So that is our objective: how to expand our urban area, how to make our cities water sensitive, how to look into the entire hydrological cycle in totality in a holistic way, so that there is an increase in quality of water which goes into the aquifer, and you also reduce the pollution of the surface runoff, which ends up into our aquifers and our water bodies. So basically, I would be giving you a little bit on what challenges we are facing in the Ganga plain, the Ganga alluvial plain, and how do you check the groundwater over exploitation? What are the options for stressed aquifer systems, especially the urban peri-urban ensemble, because there's a lot of peri-urban expansion which is happening. Rural areas are becoming urban, and there's an urban pumping race. Everybody's trying to withdraw groundwater. How to frame the zoning, especially with respect to the contaminants. We have landfills, we have emerging contaminants, we have heavy metals, we have even arsenic and fluoride, which is coming in a very big way in the lower Gangetic plain. And thirdly, I would also be talking a little bit on how to create recharge areas in the master plan, and finally on what are the technological management and policy strategies which we can try. So basically, groundwater economy, it remains the lifeline of the urban economy, and it is highly undervalued. Groundwater is always available universally. You can just take whatever amount you want to have. It is a dependable resource. You have a low capital requirement. You don't require too much on maintenance, and it is a non-excludable resource. It is a common property resource. You cannot exclude anyone from consuming it. Everybody has a right over groundwater, and we have a British act called the Easement Act, which is still applicable to the groundwater. If you own the piece of land, you also become the owner of the groundwater underneath. There is a uneven distribution of groundwater. So aquifer systems are different, the climatic systems are different, rainfall is different. So you have to have a very site-specific, region-specific planning. You cannot have one size fits all type of strategy. You should have a very site specific plan for different urban areas. There are deep versus shallow aquifer issues. Some we are eating up all the shallow aquifers and going down, but the water quality constraints are there. Salinity is coming up, heavy metals are coming up. And lastly, the groundwater economy is highly undervalued. We even do not talk into discounting it from the GDP. So there is a biggest market failure when you talk about the groundwater economy. First, we are pumping more than recharge. This is very much true to many of the cities and towns. If you go to Agra, if you go to Pratapgarh, or if you go to Ghaziabad and Meerut, there are areas where uh, groundwater draft is much, much more than what is actually going in our aquifer. So basically, we are turning into our account where you only withdraw and you do not deposit, right? So there are cases where aquifers are beginning to compress and collapse. Large cases of land subsidence is happening. The ground is going a little bit sinking because you take a lot of water. There's a huge mass loss in terms of volume underneath from the aquifer, and eventually you are going to get to zero. Like in Agra, if you see how much shallow water is there, there's nothing, because we have exhausted almost all the freshwater reserve, and there's little left in our aquifer systems. There's no legislation on aquifer protection areas, especially we have laws on wetlands and lakes and ponds, but so far we haven't been able to pinpoint or draft any legislation which could protect these critical aquifer protection areas, or I would call it CAPAs, critical aquifer protection areas. They are still outside the management radar. And wastewater, it's seen as the negative externalities, not as a resource. It is not holistically connected into our hydrological cycle, and water pricing again is trapped in a vicious circle where nobody is willing to pay, and ultimately our utilities are struggling to come out from this low revenues, our municipal agencies. So urban groundwater challenges are enormous. There are issues of regulation, there are issues of registration of users. We have the Uttar Pradesh Groundwater Act recently we framed, and we also put on compulsory registration of users and restricting use, penalties and incentives, but they are all confined to a small sector, that is industries or the bulk users. Agriculture and the domestic consumers have been left out from the legislation, and they are only the demand side measures. The supply side is still not tackled very effectively. There is also top-down approach. We think that once we enforce the regulation, it will work on its own, but we do not regard large-scale bottlenecks, large-scale hindrances into the overall operational coherence. There are multiple issues of convergence, conflicts between the departments and agencies, and even within the laws. Like if you have the electricity subsidy you give, but on the other hand, you try to control the groundwater overdraft. So they are almost like in conflict. So how to do it, how to enforce regulation, what should be the alternate approach in urban areas, who owns the groundwater, to what extent one can own the groundwater. So these are the questions which are still not answered properly. And of course, the issues of groundwater ownership in our urban areas still linked with the land. As you know that groundwater is flowing, and if I extract too much, I also jeopardize the others, ability to withdraw the groundwater. There are issues of depletion, pollution, and environmental problems, and there is no focus on capacity building of stakeholders. So these are some of the challenges. So if I summit all these points, there's a growing disconnect between public policy and emerging challenges, and we have to bridge the gap between policy and practice. There's a challenge of scale. What sort of transition we are we want to implement, or we are actually requiring, like from the drainage city to a water sensitive city, what sort of retrofitting we require, what sort of scale we have to work on, a meso, micro, or a very sort of regional scale or a local scale. Then there's a challenge of capacity. We need multipliers to implement changes, especially the institutions and civil societies. Right now, very few actors, very few stakeholders are coming forward for this very important and critical area. So if you see this Ganga basin, it covers almost like the nearly 40% of total replenishable groundwater is coming from the Ganga basin. This part between the peninsular shield and the Himalayas, you have the great vast reservoir of fresh water, and the yield potential of these alluvium aquifers are sometimes 40 liter per second, which is cited in the literature, but it is not always the same. There are large scale of heterogeneity in the the groundwater availability. If you see the consumption of groundwater, we are the biggest consumer of groundwater in the world. See, and the total extraction is almost like 26 times the water stored in the Vakra Dam. So this amount of water is being extracted from the ground every year. So there's a huge vacuum which is created. Of course, it is being recharged, but when the recharge is not happening, when the aquifers lose the plasticity, when there's a quasi-irreversible damage which is happening to the aquifers, that means once you withdraw the water, it is not a guarantee that same amount of water will be stored by the aquifers because they lose the plasticity. So basically in urban areas and also in the rural areas, we are facing four major types of problems. There is overexploitation and water table decline. There is a water logging. There is a water quality deterioration and the groundwater scarcity. If you overlay this on map of the state, the Uttar Pradesh, you see this entire western UP is having this problem of overexploitation and rapid water table decline. Then in the towards the eastern part, you have the problem of water quality. Arsenic is coming, iron is there, fluoride is also coming. Then there are in the central part, there is an issue of water logging from, you know, the rivers from Tibet and Nepal. They bring a lot of water. Soil is almost like saturated, and there is not much space. Water flows, and a lot of water logging is there. But in the Bundelkhand part, there's an absolute groundwater scarcity. There is not much left in the aquifer because there's not much layer. You know, there's a granite, and the topsoil is very less. So the aquifers lose water to the lower riparian areas. The water from if you go to Bundelkhand, it is coming to the Yamuna river systems underneath, and there is not much water for the users. So these are the decadal trends in Uttar Pradesh between 2005 to 14. And what you see is the pink color and the red color, they are all showing decline. So this is pre-monsoon, this is post-monsoon in one decade. So almost see most of the areas are having a declining tendency. If you see the decadal trends, of course, there are the water table is going up in few areas, but you have to also see the current pattern, taking the data which is quite recent. These are the cases of land subsidence which is happening in Hamirpur, Jalan, Urai, Rai Bareli, Allahabad, and Kanpur. Many such cases are coming up because of rapid and high volume of water extraction. These are the stressed blocks, but that scenario in UP, all these red and the black areas, the red areas are the overexploited blocks, and the blacks are the critical. So their numbers are going up. This is the figure of 2011, but if you see the recent figure and this graph from 2011, 111 blocks, it has gone up to 113, but it has gone down, and some areas showed like increasing, the water table increased little bit, but absolutely if you see the total area, the category wise blocks, many blocks are coming in the overexploited and the critical categories. And the average decline in major cities they are sometimes as high as 1 meter per year. These are the average figures, but if you go to Kanpur or certain pockets of Agra or even Lucknow, in some areas, this is showing only 70 centimeter, but actually it is 1 meter per year. That is the quantum of the groundwater table decline. So recently we tried to cover 22 cities in UP to prepare a groundwater conservation mission. And these are the areas where the urbanization is happening on a huge scale. The concrete is replacing the other the softer land use like agriculture and the parks and the recreational areas. A lot of land use is changing, and there's a shrinkage of areas which could retain water for recharge. So there's a rapid decline in infiltration rate, and there's a rapid increase in runoff because of concretization in these districts. So coming back to overexploitation, water table is highly variable and unstable. If you see the data, both long-term and short-term fluctuations are happening due to rainfall and due to recharge and discharge factors. And there is a deep water level zone within the city where there's a high pumpage, very heavy pumpage of groundwater. And those deep water level zones are confined in the city pockets in these emerging urban cities. Now, coming back to the mass loss, I mentioned this term. Generally, we measure the groundwater table decline in inches, centimeter, or meter. But imagine a volumetric loss, right? NASA did one study using the GRACE satellite, and it was published way back in 2009 that we are withdrawing almost 54 kilometer cube per year of groundwater, right? Per year. So that much of volumetric mass loss is happening from the aquifer. So that much of space is created. But once you lose that much of water, there's a decreasing groundwater storage. Aquifers are not fully being recharged. So aquifer reversal, I mean, the reversal may not happen. There was a case study in Jaipur that if the rainfall would continue like this, and if we stop the groundwater extraction, that it will take 84 years to fully recharge the aquifers. The reversal of aquifer would happen only in 84 years. So once you dewater the aquifers, there is a quasi-irreversible degradation of aquifers. A lot of intrusion of salinity is happening. Polluted water is coming from other states, transboundary areas. Aquifers are also transboundary. We share aquifer margins, aquifer boundaries with our neighboring countries as well, because these Gangetic alluvial aquifers are quite vast. These are some of the figures I quote before you on the scale of groundwater table decline. This I took on 3rd of September, just 3 days back. We have the automatic water level sensor, and this is in near Agra, how the water table is declining with respect to time and with respect to pumpage, from 47 meter to 46.9. And so there is a lot of change is happening. I mean, it is not very static. Similarly, in Allahabad, the water table is below 23.7 meter below the ground level, and this is in Fatehpur, Narayanpur area. Similarly, in Lucknow, in Polytechnic College, there is one groundwater piezometer, and it is showing 42.89 meter below the ground. So these are the urban centers where rapid decline in water table is happening. So we may question where did all groundwater is going? It is going to meet our urban demands. This is another piezometer in Lucknow, and see the data from 2012 to 2015. The water table was 9.87 meter below the ground, but it went to 15.85, almost 6 meter decline in just 3 years. And this is happening in one of the areas near Telibag in Lucknow. Coming back to Agra, most of the blocks, rapid decline. If you see the rainfall pattern in the last 22 years, except 3-4 years, all the years were deficit years. Rainfall is decreasing. In many districts, we are witnessing this data, Bundelkhand and even the eastern UP and the western UP. The rainfall is decreasing. Last 2 decades were normally deficit decades, and see the quantum of deficit from minus 34% of long period average to 44%. Only a few years, like 2013 was little more than the normal rainfall of 651 millimeter. So this is happening in many areas, and that is leading to the groundwater table decline in our cities. Coming to the second part of my presentation, why there's a loss of critical aquifer protection areas. What is happening in our cities? I'll give you one example of Lucknow, where we are working. We lost almost 70% of wetlands due to land use change, due to encroachment, due to many colonies came up, highways came up. And if you take these 2 urban areas, the urban centers in Chinhat block and some areas which are sprawling, there's a peri-urban sprawl towards the southern part of the city. We are encroaching upon these minor drains, wetlands, and smaller rivers. The southern part of the city is draining into the Sai river. Okay, so this is Gomti river, and many important drains like Nagwa drain and Buck river, they are all disappearing. They are disappearing from our revenue map because we do not consider this drainage map when we make our master plan. So what we did, we took the master plan of different local bodies, and in Lucknow we have the Lucknow Cantonment Board, we have Uttar Pradesh Housing Development Board, that is Awas Vikas. This is their master plan, and there is another Lucknow Development Authority master plan. So we tried to overlay all these master plans and prepared a map of land suitability, carrying capacity, morpho land use. So morpho land use and the carrying capacity maps you have to prepare. There used to be a town and country planning organization, and they used to prepare the land suitability map. So once you overlay these housing, the master plans, you would know the conflicts in the urban expansion. So what we did, we created a series of iteration. We prepared a multi-criteria evaluation model where we use the satellite pictures of different years. We define land use types based upon attributes of the land use, agriculture, or they had different utilities and attributes. And based upon the overlay and the suitability maps, we calculated the conflicts which is happening vis-a-vis the master plans are concerned. So we took several criteria like soil suitability, land use suitability, infrastructure suitability, morpho land use, and you see the water is groundwater geomorphology, groundwater depth and quality. It is everything is coming up. And when we did this model, we saw that many natural areas are coming into transitional land use. That is, the dense forest, open forest, water bodies are either becoming wasteland or scrubland, or they are becoming the natural is becoming urban. So there's a critical loss. So when natural is converted into transitional, or there is a conversion of natural into transitional and natural into urban, there is also a loss. So we calculated these for Lucknow, and all these red areas that you see, it is the loss of the land use values. We define land use attributes and the values depending upon these criteria. So due to peri-urban expansion and the growth in urban areas, we are losing such critical areas every year. And we also created as micro maps for different areas in north and south and east and west, and we saw that such red areas, which is loss, which is irrecoverable loss, which is happening at the cost of wetlands and water bodies. So these are the land capability maps based upon the groundwater table, the elevation, the soil, and all those geomorphology and rivers. And so I will not go into detail, but based upon this urban suitability map, we did one exercise for Lucknow. We came to know that only 1/3 area is suitable for urban expansion. We took both fuzzy logy and the AHP model, and we came to know, and this is also applicable to other cities. If you want to develop, if you want to take into account the carrying capacity, the morpho land use, the land suitability, 2/3 of the cities should remain with a healthy land use, like agriculture land, pasture land, water bodies, recreational areas. Only 1/3 areas should be concretized. But that was a highly sort of uh, scenario which is not liked by the urban planners or the land agencies, because they want to expand cities. But if you want to respect the carrying capacity, you have to respect all morpho land use and land suitability parameters. So these are the land use conflicts, where you plan for built up areas, areas which could have been designated as critical aquifer protection areas, right? Similarly, we saw the buildings or the urban expansion coming up on paleo channels, on water bodies, on smaller streams, on rivers. So the land agency is not able to incorporate the drainage and such high value environment into their planning process. These are the pictures of the wetland which is being encroached by the housing, informal settlements, or what you call the private colonies. They are doing plotting inside a wetland, and we know it, but we are unable to act in time. And once we wake up, the damage is done. Similarly, take the example of river, which is a master drain. So if you see the older maps, these are the groundwater contours and the gradient of flow. The groundwater used to come towards the river, and the base, due to high base flow, the river was affluent. It was perennial and the river was flowing. Groundwater used to contribute to the rivers. But in 2015, we came up with a riverfront project. We jacketed the river, we concretized the floodplain, and we restricted the pathway of the channel. We restricted the channel width. So as a result, we lost these critical recharge areas. These areas, nature reserved it for recharge. So we lost the water which was coming from the ground to the river and ultimately to the lower riparian areas. So we calculated the flow duration curve and environmental flows and the base flows. If you see the base flow, the river used to get high volume of groundwater as base flow. But due to jacketing, due to unhealthy land use, we are losing this base flow or the groundwater influx into our river systems. And these are some of the examples. If you take the basin, we wanted to understand how the groundwater is affecting the other lower order streams in our urban areas, even in rural areas. We took the entire catchment and we started recording the groundwater decline into for the entire basin. And these are the results. This is 2006. This is post monsoon 6. This is again in 2005 and 10 and 15. So what is happening due to decline in groundwater table, the rivers are becoming seasonal. Rivers are becoming intermittent. So the rivers which used to be perennial, they are losing water, and this is happening in just few years, because ultimately if you lose the water, you lose the river, right? So the connections are very important, and that's why I wrote recently one article that rivers also need groundwater. So there's a legitimate requirement of rivers also onto this subsurface water, and that kind of vertical connection must be respected by the urban planners. Now, coming back to the critical protection areas, all the floodplains should be demarcated. All the terrace of the rivers should be demarcated in urban areas, and they should be declared as water sanctuary. These are the areas where you get high volume of rainwater and it recharges your aquifers. Similarly, smaller rivers, even in urban area, this is the Kukrel River, and you see these areas also, they are the storehouse of fresh water, and you have to restore these smaller rivers to maintain the continuity of flow. Coming back to the third part, the contamination, we observed that there's a high permeability rate in the floodplains. There's a return flow of sewage into the groundwater through natural drains, because we are converting natural drains into sewage carrying nalas, right? Nature made them as a natural drains, but due to default, we puncture sometimes even the our sewage system and connect to the natural drains, even a stormwater drains. So that sort of system, or that sort of retrofitting should be avoided. Shallow water table in some areas, they are in direct contact with water table and pollutants. We have seen that, especially during the post monsoon, the water table comes up and it meets the polluted water. There's a lot of exchange of nitrates and other pollutants. The contaminated surface water infiltrates into the top shallow aquifers and it moves into the deeper levels. So these are, we took some of the landfill sites, and we took 4 sites which were the old dumping waste sites in Lucknow, and we monitored the groundwater, the impact on groundwater. So we calculated both the quality of the leachate, what was there in the leachate and what was there in the groundwater, starting from 500 meter to this landfill site up to 5 kilometers. So we took a lot of data, and these are some of the figures.
We are running short of time,
right.
So please do it fast.
So how much time I have? 5 minutes?
Yeah, 5 minutes.
Okay, so I'll conclude in 5 minutes. I will not go into detail. These are figures. So the basic idea was that these leachate, they were traveling down to the aquifer and they were contaminating the groundwater. So a lot of heavy metals we observed, copper, nickel, iron, and these are in the groundwater, right? So arsenic, chromium, and we also observed that like we monitor up to 5 kilometer, the plume, and there was sometimes it was decreasing, but it also increased, because it also depends upon the flow gradient, how the groundwater is flowing. So the contaminant may not be in a high concentration near the source, but it may also go downwards, sometimes 1 kilometer from the landfill site. So basically, if you want to have the contamination risk zoning in urban areas, you have to have the source of contamination, the data on subsurface geology, the depth to water table, and how the subsurface flow is happening in the aquifers. So we found that there was a decreasing concentration of contaminants with depth. Shallow aquifers gets polluted due to industrial and domestic effluents, and there's a soil organic matter also. They are connected to the availability of metal. Wherever soil organic matter was high, we also found association of some heavy metals. And after monsoon, the parameters decrease significantly, right? So these are some of the areas where the water table is high, but due to our domestic sewage, the nitrate and all fecal coliform, they're also affecting the water table. So this is what we want: natural drain with vegetation buffer, but this is what we have. All the natural drains have been encroached by these squatter settlements. So these are some of the studies we did in Kanpur. Again, we saw a lot of chromium, the water is almost like yellow. Then in Fatehpur, we saw fluoride, high cases of dental and skeletal fluorosis happening in Fatehpur. These are all from my areas in Chittapur and one more block in Fatehpur, where chronic fluorosis is happening. Again, on arsenic, I will not go into detail. The entire Ganga belt, especially in the eastern part, is affected. These are the summaries. So coming back, the final part, we must have a catchment planning approach for long-term development perspective. Urban development should be based upon constraints in river catchment area and the future prospects of water supply from the river. We have to expand peri-urban areas only when there is a groundwater and surface water is available and there's a recharge prospect. All the water storage, habitat, and the nature-based water treatment should be combined with the new urban development. So these factors are not taken into master plan. So even the nature-based water treatment, DWATS, decentralized wastewater treatment system, should figure out the wastewater should be relooked as a resource, and reuse policy should be framed for urban areas, which could ease stress on the groundwater. Master plans and zonal level plans should designate the sites as protected groundwater recharge zones, the floodplains, the paleo channels, the oxbow lakes, the wetlands, or in the ponds. They are the discharge areas also, but they also become the recharge areas due to loss of groundwater. Areas with groundwater prospect should be reserved for clean land use. And those construction industry, there's an unaccounted groundwater. They use groundwater during construction process, and it may take 10 to 15 years before the housing could come. So all these construction activities should only be provided with recycled or treated wastewater. There's the issues of convergence and coherence. We have many plans, many process, bylaws. Extraction limit is also being talked in the groundwater bill, but they are not integrated. There's a lack of vertical and horizontal coherence. And finally, these are my final key recommendation. We should prepare the groundwater vision document for every district. We should prepare a 100-year aquifer management plan, not just 5 years or 10 years. We should have a 100-year plan. We should have a micro level aquifer mapping, more reliable data. Aquifer maybe as at 1:10,000 scale, or maybe 1:5,000 scale. We have to check the unregulated and excessive extraction. Regulatory power is not currently being utilized. Conjunctive management, both surface and groundwater, should be used properly. Regulate rainwater harvesting system and create groundwater sanctuary. These are the critical aquifer protection areas. And finally, evidence-based planning policies and provisions. So that's all. Sorry for taking too much of time, but I thought I should cover these points, that is contamination, recharge, and the protection of critical aquifer protection areas. So if there is any question, I'll come back later.
Thank you, Professor Venkatesh. That was very helpful. And thank you for your detailed study of the UP and the context of the plains. I think this is very helpful and provides a lot of touch points where you mention things which are also very common to the CSC approach of water, looking at urban planning perspective for groundwater, which came out in your present conclusions as well. And some of these issues which we normally hear, but there is very little evidence. For example, the fact that you are giving is that there is a collapsing groundwater aquifer, aquifers are collapsing, and their ability to store water is also getting reduced. So normally we study about these, but with evidence and with latest data, we don't have. So thank you, sir, very much for your valuable ideas. I'm sure what we will do, sir, is we'll have some kind of feedback at the end with all the questions, or if you can see on the chat, if there are any questions, you can keep responding directly to them. And now we would like to invite Professor Shashank Shekhar and request him to also share his presentation.
Thank you, Dipandaji. First, Professor Venkatesh Datta from Lucknow, an academic and an environmental activist from the city of Lucknow. Then Dipandarji and the dynamic coordinator, Charu. I will be sharing some of my experiences and the works which we have been doing in state of Delhi. Urban hydrogeology is a challenge, and it's an emerging challenge where subject has to adapt itself to that challenge. So going to the next. I think I must, yeah, perfect. So this has to be brought down. First, this has been pointed out by the previous speaker, aquifer mapping, not only aquifer mapping, groundwater potential delineation, delineation of the aquifer heterogeneity, and potential aquifers to be identified. Then what is horizontal and vertical variation in groundwater quality? What are the anthropogenic and geogenic forcings in context of water pollution? Then vulnerability of the groundwater system to pollution, source sustainability, ways and means of augmenting the groundwater, reserve. So let's take this up somewhere here, or that's better. What it involves effective policy framework, and that has to be based on rigorous scientific research, not just a top-down approach where a few technocrats, bureaucrats, and academics sit in a room, huddle in a room, and prepare a policy framework. Effective governance measures, and that too in consent with the masses, where the approach has a bottoms-up approach. That is, masses have to be sensitized and integrated into the governance measures. And of course, if you don't have people's participation, it is all useless, because you can make n number of rules, and people can find n number of ways of not obeying them. It's not moving. My slides are not moving. Charu, I think I made it next. Shall I do enter? No.
Pardon, what is happening?
The
slide is not moving?
Yeah, it's not moving. Okay, now it's moved. So I think there's a drag it somewhere here. So some of the conventional approach are, they're like demand side management and water conservation, supply side management, water resources augmentation. They are good. They're not good, but they had to be more integrated in approach, and hence what is desired is an integrated water resource management. We will quickly discuss the aspects of conventional approaches, and then maybe go back to the next. I think there is some problem with this.
So shall I share the presentation?
That would be better, because from my side, the slides are not moving.
Okay.
So if you can stop share, then we will put it on.
Okay, I think if it's good at this scale, then maybe it's okay. Perhaps here it will move. Yeah. So the aspects of demand side management, enhancing water use efficiency, less showers, not no showers, proper shaving with mug of water. In industrial sector, a lot of value addition in cooling process is required. It is a water guzzler process. And then we have to work on condensate recovery. A lot of water can be saved. Industry is doing, it's not they're not doing, but some more innovations and compliance is required. More crop per drop wherever you are growing. Water efficient gadgets, we have adopted to biourinals. Biosystems have come. Only we are waiting for water efficient washing machines. Then high-end users have to pay commercial rate. We have not implemented this. They have to pay, they cannot pay the domestic rates. Second thing, which I had been shouting for some time, perhaps it has not reached the decibel, all multi-storied houses should have water meter in individual flats. Rather than the water tariff should not be included in maintenance charge, because maybe they are the high-end members of the society, but many of them are not water sensitive and not environmentally conscious people. They waste a lot of water because there is no separate pricing for the same. Supply side management aspects, leakage and pilferage control, that's a big problem in urban areas. The water is subjected to thefts, and it's not uncommon. And then there is a lot of pilferage. Dual water supply, some parts of Delhi we adopted it, but now not many new upcoming towns are having this. And ZLD's colony, zero liquid discharge colonies. All the sewer of the colony is recycled and reused in the colony itself. That's an urban water management strategy which can sustain the urban centers in city. Industrial units to be ZLD, yes. And all the cooling requirement, mopping requirement, washing requirement of industrial premises, they need to be met with the treated water. There should not be fresh water, for them. Assured and timely water supply so that you don't have taps left open phenomenon. This happens many a times in most of the urban agglomeration. Your taps are open expecting for the water, and though maybe you have checked them, and then suddenly water comes and it floods it. Now the proposal is that groundwater stressed areas should be supplied with surface water sources, and the areas where there is a lot of surface water, it can be diverted to the other areas. I will add in this, because now the focus is on high density population in a very small area by way of making multi-storied houses. And there we have already suggested in some of our earlier reports to government, including Lucknow water for the Lucknow city, that the first priority of surface water supply should be to the multi-storied houses. And the gazette notification of CGWA has already waived off the mandatory need for permission in case you are making a tube well only for drinking water purpose. So if an individual household is in a shallow water level area, he can make a tube well for drinking or a hand pump for drinking purpose. But you just can't meet the requirement of a multi-storied house just from groundwater sources, because it's a high density population in a very small area. And this sort of prioritization has to be done. Water resources augmentation, adhering to environmental flow of a river in any city augments the groundwater and water reserve. And that is not being done exactly. Natural water bodies have to be mapped, conserved, and rehabilitated. That is not being done in many parts, but Delhi has done. Natural wetland conservation, artificial water bodies and wetland, flood water harvesting, treated sewage water, rainwater harvesting, and then enhancement in flood-induced recharge. This we will discuss quickly. Now see what we have done in Delhi is that this was a project where I was involved as a CGWB hydrogeologist. I think many other earlier talks also I have discussed this. We have a river Yamuna here, and every year it floods within the embankments. And earlier the water level was shallow here, 4 to 5 meters below ground level. City needed water, so we made some 100 tube wells here. Amongst them, with 60 I was associated, the initial ones. They look very close to river, but except a few, most of them are 1 kilometer or more than half kilometer away from river. And then in the lean sea, we are pumping this out. We deliberately do a scientific desaturation of the aquifer here. We desaturate this aquifer and bring the water level from 4 meters below ground to 9 meters below ground level. So it comes from 4 to 9. You have created a subsurface space, and then we allow monsoon flooding to take place. So these are my tube wells, and this is monsoon flood. This is not river. This is monsoon flood. So the monsoon flood replenishes the aquifer, and during the month of November, again the water level comes back to its original. So this is a kind of managed aquifer recharge. And this was a pilot project from where we gave 2 lessons. First, river space must be defined and the floodplain must be conserved, not for the sake of non-tangible benefit. It has tangible benefits where it can be utilized in terms of money. This water extracted is sold, so it has money. And that is what we could argue in Delhi for conservation of the floodplain. The second thing is that this example can be replicated in most of the towns which are situated on the banks of monsoon rivers, where similar things can be done. there were concerns. It is not that there were no concerns. There were concerns. So I will quickly summarize. The tube wells extract water to the tune that there is no significant lowering in the water so that farmers' tube will go dry. That was first term of reference. Second, there should not be upconing of saline water from below because the area has saline groundwater below. So pumping was restricted to this volume. Third, there should not be significant depletion in the river head, which is flowing by its side. So though the tube wells are roughly, if you have 100 tube wells, they have capacity of 50 mgd, but it was toned down to 30 million gallons per day so that it suits the socio-economic and political perspective of the region. Now, the floodplains have value. The annual water yield from floodplain aquifer in the Pala well field is rupees 750 crores per annum. And so in last 20 years, when we made this has on a renewable basis yielded water worth rupees 15,000 crores. And that too, then it was only 10 crores of the investment, 10-15 crores. So this sets the tone for urban water management, that you have to identify the potential aquifers, look for a renewable resource, preserve it, and then you develop it. So these are the same tube wells where on-site chlorination is done. This is an artificial recharge structure. The next approach which we are doing in Delhi is that water body rejuvenation. This was done by Shramdan of the fellow citizens, but now government has taken up because the decibel of voice by so many people has reached that level that government has formally commissioned a water body authority. They have recognized 1,000 water bodies in Delhi. They are going to preserve, rejuvenate it. And we have worked upon it that each has its own value and capability, even of forget the ambient ecosystem. Even a few tube wells can be made there to supply to nearby areas. Now, this is a new dimension which cities need to move towards. And because you just can't make houses and leave people high and dry and keep waiting for canal water or a dam water. Given the fact that whatever water you take, exclude 30%, rest of, if maximum 30%, rest comes back into the system as sewerage or as a grey water. Now, managed aquifer recharge, Pala was one example of managed aquifer recharge, and soil aquifer treatment. I have a caution here. City State of Delhi has started this in some places, but let's be careful. Let's adopt the precautionary principles and just not follow the protocols. So managed aquifer recharge, almost all of us know, it's a deliberate recharge of an aquifer so that you store water like we are doing in Pala, and then use it sometimes later on. Soil aquifer treatment is a method that recharges appropriately treated wastewater. Means there is a STP water that is taken to a basin or a water body, and it recharges the groundwater system, and then it has to be confirmed by a study that the source water had the adequate quality, and while recharging, the water quality has improved. Any such mass effort or big effort should be preceded by a pilot project which is adequately monitored and rigorously examined. You just can't do it blindly, because site is a big word now. Every cities tend to do it blindly. No, it requires soil which should be permeable. You just can't do it in clay, and should have optimal infiltration rate. Then large sewerage, treated sewerage volume is required, and a good treated sewerage volume. Then you should have the kind of soil which is fine sand, loamy sand, sandy loam, not a very coarse grained sand and gravel, because the adsorption of the pollutants take place in clay, sand, and other things. So it should be an admixture of that. Then the vadose zone, the unsaturated zone, should be sufficient. You can't just make a SAT system, soil aquifer treatment, in a waterlogged area. Or the punchline, if you say the standard operating procedure should be that wherever you can make a rainwater artificial recharge structure, that is, wherever the depth to water level is more than 5 to 8 meters and the area is showing declining water level trend, only in those areas soil aquifer treatment should be attempted. Not in other areas. Preferably below the bottom of the pond, there should be 10 meters of unsaturated zone of adequate quality material. Though European Union says 1 to 2 meters, but that is in the case because if you put water in this pond, then the water level rises here. So the regional water table should be 10 meters below, and locally it will be a mound. This thing I wanted to stress, never ever we should try in fractured rock aquifer. These are from international research protocols. Many a times out of enthusiasm, the cities are going to hard rock areas and they will think of putting the treated, sewerage there. No, because hard rock aquifers does not have this capability of absorbing those pollutants and improving the quality. Then shallow soils underlay is not suitable. But that's fine. EPA says this but 2 meter just below that. Ideally, it should be 10 to 30 meter. A specific soil permeability, that's fine. This problem has not been greatly recognized. See, when you put that water there, your water is also interacting with sediments. Sometimes it can leach chemicals out of it and may result in elevated manganese iron fluoride. So that condition has to be. Then anaerobic conditions in the soil should not be created, and the nitrogen fixation cycle should not be inhibited so that you have high ammonia content, or else it reverses the whole objective of the project. And soil aquifer treatment has a limited capability to treat certain contaminants. You just can't think of putting the industrial effluents in it. It should be domestic sewer. And there has to be a proper design. Clogging of the basin, that can be, and chemical precipitation can be taken care of by annual maintenance. The catch point is that the cities have to move towards this and maybe redesign their drains and water bodies for this, but not just in a blind way. After a pilot project, and then in a suitable hydrogeological condition, and under regular scientific monitoring. City of Delhi is doing this at a few places, and that's why I wanted to flag this point here. It reduces evaporation and natural buffer, that's fine. That's fine. Disadvantages: you can add nutrients into groundwater system. If you're then space, that's fine. Vulnerability to clogging. Most important, pre and post conditions. This is from my side, not from any book or paper. We must regularly characterize the source water. Very often the functioning of STPs are questioned in India. So there has to be continuous online monitoring of the source water, especially with respect to BO, BOD, CO, DO, and other things. Then infiltrated water characterization. We should have a nearby observation well, which should be taking the samples out from the groundwater, infiltrated groundwater, which is the groundwater system, and continuously monitoring it. And the pilot project should not be approved for a BPR in other areas unless and until there is an impact assessment study. Quickly, Yeah, all of us know what is BOD, what is COD, and what is DO. So then you can't accept eutrophication in a SAT project. Then it's a big failure. We shouldn't be doing this. Then the cities have to look towards alternative sources of water supply, development of brackish water aquifers if they are there. Must aim, if the municipality or the body has money, it should aim for desalination. And the biggest resource is treated domestic water and industrial water. So recycle and reuse. Now the challenges which most of the cities are facing is river water based supply and groundwater based supply. They have their own advantage and disadvantage. But the problem is that river gives, that's the advantage, not a problem. River gives a bulk source at a place. So you get a good volume. So pipeline cost is economical vis-a-vis volume. But high infrastructure cost, mandatory water treatment and recurring cost, raw water quality is vulnerable. We have been seeing in Delhi, sometimes there is ammonia, sometimes there is something. It's a monsoon dependent. Groundwater system, hardly any treatment is required. It gives in situ local solution, can be planned near to demand. Wherever you have demand, you can develop. It's a disaster mitigation, not easily vulnerable to contamination. But the problem is one tube well has a very small volume. So if you have two tube wells, you can't think of a pipeline. So most of the time, we have to think of a well field from a potential aquifers for an urban supply. All these conventional management practices, they were mostly centered around tops-down approach, highly technical, and there was not sociological and ecological integration. And, it failed to see the intricate relationship between land, equity, and environment. And thus, cities now need integrated water resources management, which should be an alternative development paradigm for which most of us are talking in from different angles. So that's fine. It's an environmental, ecological, socioeconomic, and political perspective. Then equity is one of the most of us have been discussing this. All cities have haves and have-nots, rich and poor. And very often the areas which are, poor, where poor people of the city lives, they get meager amount of water supply. None of the cities in India have equity with respect to distribution of the water resources, which we need to endeavor for. Then economically viable, that's fine. Environmentally sustainable, that's okay. Integrate everything, water economics, source sustainability, wastewater, and all this. So this is an ideal diagram from one of the blogs I had taken in 2018, where they say that you have to integrate WTP with STP, and then there should be a return flow. So it's yeah. Now, water quality challenges. And this is a punchline: the drastic and apparently visible anthropogenic alteration to water quality is mostly an urban phenomenon.
Sorry to interrupt you. Only 5 minutes are left.
Okay.
Yeah.
Okay, Charu. So we will quickly have some of the examples that most of us know. That what are the sources leaking from STPs, ETPs, and other things. These are the pollutants in an urban groundwater or water system which needs to be now monitored. Pharmaceuticals, pesticide, beauty care products, because most of them are known to have adverse effect on hormonal secretions. And this is a landfill where leachates are flowing down. This is an urban hydrogeological headache or urban water system headache. Then we have a petrol pumps, from where if there is a leakage, it contaminates and pollutes the groundwater system. So we have discussed this, ZLD's colonies. For industries, I have a strong take on CETPs, that is common effluent treatment plants. Most of the times they have been reported by the stakeholders who work on the ground that they are malfunctioning. There has to be zero tolerance towards malfunctioning of CETPs. And strict monitoring and punitive measures are required. Incentives for green units. Landfill sites have to have a proper site. You can't have a Bandhanwari in Aravali Ridge, to which we had opposed, but still it was made. You can't do that in a recharge area. Oh, that's fine. This is city of Delhi, which has grown like this and urbanized like this. And quickly a take on this. City of Delhi imports almost 87% of the water which is used is river water, and it uses Satluj, Yamuna water and Ganga water. More than half of the water which Delhi residents use is river water, which is imported from other basins, not its own. And then we'll forget the geology and other things. Quickly coming to the way here. As per the seasonal allocation of Yamuna waters, Delhi has hardly any more water available in lean season. In the monsoons, it can have some 300 mgd because 250 mgd of treated effluent have to be given to UP as well. And as such, there are only two options of water supply, augmentation of water supply to Delhi now. That is the floodplains, where on a lump sum basis, 200 mgd can 30 mgd right from Palla, and if you increase by 170 mgd, so 200 million gallons per day can be water can be extracted. And see, each square kilometer of floodplain in Delhi gives water worth 30 crores per annum. So, and then the next is the sewer water. We have 607 million gallons per day of, million gallons of the treated sewerage water available. So they have to be, and the ultimate demand of Delhi would be, in another 10 years, would be around 530 million gallons per day. So if some 300 mgd is released to lower riparian state, so 200 mgd from the floodplain, and bringing this 300 mgd into the water system by proper treatment can solve the problem. Some suggestions: park with pond. That is required for all urban cities. Most of the ponds which have rainwater harvesting structures or AR structures, artificial recharge structures, they are non-functional. I go to them, examine them. Then local depression in natural landscape may be identified, and we can develop them. That's fine. That is already said. Then, so we need newer water supply, assured and timely water supply, water positive lifestyle. So for any urban agglomeration, the potential floodplain aquifers, first, because we can take advantage of the monsoon regime in India or in any other parts of the South Asia. And then treatment of the appropriate treatment of the sewer water for domestic use as well as for managed aquifer recharge through soil aquifer treatment process, where we can augment the groundwater reserve. That is a focus areas which can solve the urban water problems in future. That's all. Thank you, Charu.
Thank you, Professor. Thank you for your lecture and informative. We had asked you also to share about the Ganga, about the Yamuna work. So thank you for sharing that in detail. And Professor Venkatesh had shared about the UP one. So both are very useful for us. There are, sir, some questions in the chat box and in the question and answer also. And they are asking, one question was on this water sensitive, this spawn city concept. So one person, participant, Mr. Devashish Sarkar, has asked, can spawn city concept be implemented in India? China is working successfully on this concept, and Chennai is among a few cities in India which are in the primary phase of implementing this policy. But what will be the concerns for this? So both of you could, come on this, because this is a thing which we hear very often nowadays, the spawn city concept.
I think this concept was basically, it came from China, and many cities are now termed as spawn city. If you see the example of Singapore, where there was this project called ABC, Active, Beautiful and Clean Water, where they retrofitted even the built river space into a natural river space and created more space for flood water, created more space for water to retain, to to have better recharge prospect. It is a very good concept, but we need to see the scale, like the kind of scale, the kind of the catchments we are dealing with, the Ganga basin and many sub basins. So I think the basin approach would be very similar to this sort of spawn city, where you use the water, reuse it, and return back to the nature. So basically the idea is to see the entire circularity of water, the entire circular aspect of water. We talk about circular economy, but in a spawn city, the water is used, reused, and returned back to the nature, creating more space for both flood and the dry phase, the wet phase and the dry phase. Thank you.
Yeah, that's fine. The good aspects can always be taken, integrated with our own practices. Yeah.
There is also this issue that, like the Chennai example, is that you need both drainage as well as recharge, because the Chennai gets flooded, whereas the coastal areas need recharge to prevent salinity from coming in. So how much is spawn city, applicable to the diverse context of India? So it's as an overall concept, nobody will question the validity of, but are there enough sponges? So Manu Bhatnagar in one of our meetings had raised this point. We talk of spawn cities, but are there enough sponges, or where they are needs to be identified? And both in the case of UP as well as Delhi, for example, in Delhi, Manu Bhatnagar actually showed that there are sponges, but they are limited to certain areas in the city on the map. And Professor Shashank Shekhar also, in I think one of his presentations earlier I had seen, had shown that. So, those things are, a little problematic for us, whereas we have no quarrel with the fact that we should conserve as much water which is possible.
Yeah.
Next question.
So there is another question from Harshit Gupta, and he has asked something about the Bundelkhand Expressway. He said that groundwater exploitation was reason for Bundelkhand Expressway failure or something else. So actually he wants to know what is the reason behind the failure of Bundelkhand Expressway. So if...
No, Professor Venkatesh, you want to take this Bundelkhand Expressway failure reason?
I haven't heard of this. In fact, I'm not aware of this expressway failure. So I don't think I could add anything on this front.
Okay. See, this could be a inquisitiveness from a participant, that how caving of surface during monsoon rains was a happening phenomenon and will keep happening in future. That's the reality. It's a natural process. Now, even if you make a very concrete structure and the subsurface soil flows away, it will fall down. It needs a proper investigation whether there was one has to be that the quality of construction was not good. That the concerned department will always look into. But what else? What else? What else? Was it some geological thing which triggered it? That can only be said once you investigate it. It's too premature because it just happened. Okay.
That is fine. And I think without much evidence, we cannot comment on this thing which has happened somewhere. And that would be a commentary as well. There are some other very generic questions, but as concluding remarks, if I would give you back about 2 minutes to summarize, or what is the key messages for us, I think let's do that. So I would start with Professor Datta, if you would like to say something.
See, we are already witnessing to a scenario where there's a huge impact of the built space, the urban space onto our natural environment, right? Many cities are coming up with master plans and regional plans, so, and even the zoning regulations. So this is the right time where we could intervene, and we could go and talk to them and ask them to make a layer of extra layer on the master plan on the waterfronts and water environments, the natural environments, right? How much resource endowment we have, what is the carrying capacity of the city, how do you define the morpho land use and the land suitability for the future growth? Do we have enough water to sustain the ever-growing population? So these are the questions we must ask and create a sort of regulation, the zoning regulation, which is very important. Second question is, we have to ask how much urban we can go. My study showed that even in Lucknow, which is almost like 2,500 square kilometer, so you can only go urban, for example, say for 700 square kilometer. So out of 2,500 square kilometer, you should be urban only up to the extent of, like maybe 1/3 or little more than 1/3. Rest of the areas should remain for our future, like the real estate bodies and the land agencies. They have a high premium on the built space, the urban space, but the water is not valued properly. Natural endowment, the natural capital is not valued properly. If you have only urban, from where you are going to regenerate climate, from where you are going to have the microclimatic impact on the other secondary ecosystem services, from where you are going to get water, from where you are going to get the recharge space. So we must consider these zoning regulations. The master plans should be water sensitive. Water sensitive master plan is the need of the hour. And I would also request both the vertical and the horizontal departments. There is a need of convergence and coherence, both like policy coherence and the coherence in terms of practice, right? We have very good crafted laws and regulation, but it is not implemented. We do not have the institutional capacity. So parallelly, we should also have the institutional reform, the kind of the critical mass at the base of the pyramid, the institutions, the civil societies, right? Then only we could go from a drainage city to a water sensitive city. So that is what I wanted to add here.
Thank you, Professor Venkatesh. And Shashankji, if you have any.
Yeah, Professor Venkatesh has said so many things. I have hardly anything to add, but the fact that we have to be water positive in our approach when we are looking for a water sensitive plans. I think all these maps should have the waterways marked on them. And if you remember in olden days, when there used to be a road, there used to be many waterways below the road. But the new civil engineers have forgotten this. They are not making waterways. And that's why the problem of waterlogging. Second, recycle, reuse, and recharge, the triple R continues, but we have to bring more gray water in drinking water chain for the cities, because we are talking of the urban groundwater or urban system. Unless and until we do this, we can't look for a sustainable city. We will have to keep importing water or looking for many other solutions, because only 30% of the water which we use is held back in the system, up to the maximum. Rest comes, and the domestic sewer is not a big problem. It's a very small treatment challenge, except the mindset that you can't bring it into the drinking water chain. Maybe if you can't do it directly, do it with SAT, do it with the soil aquifer treatment or some other. That will only provide the way forward for sustainable cities in context of water resources. Yeah.
Thank you, Professor Shashank. And with that, I would like to thank all the participants also who have been with us today. The presentations will be shared, the recording will be shared with everyone. I would also like to thank my colleague Charu. She is also leaving CSC, so I would like to thank her for her services to CSC and wish her all the best in her next endeavor. So on behalf of CSC, we would now close this webinar with thanks to both the speakers and to the participants. Thank you, sir. Thank you very much.
Thank you, sir.
Thank you. Pleasure. आप सबसे मिलके बहुत अच्छा लगा.
Thank you so much, sir. बहुत बढ़िया लगा, and wish you all the best.
And hope to continue our association further.
Okay.
Sure.
Thank you.